All right, welcome back for the second part of this organic chemistry stuff. Now we're going to talk about how things are named and then how different names mean things. All right, so in any word, you have prefixes and suffixes. Let's talk about the prefixes. So prefixes come before the word. So anytime you have carbon, if you have one carbon in the formula, the prefix is going to be meth. All right, second one is going to be eth. Third one is going to be prop. Fourth is going to be bute. Fifth one is going to be pent, and this is where we start getting to the namings you might run into in math. 6 is going to be hex. 7 is hept. 8 is oct, like an octopus. 9 is non. And 10 is dec. Okay, so anytime I have any number of carbons, so if I have 3 carbons, it's going to have a prop in there. So that means there's 3 carbons in the molecule, or 3 in the longest chain. Also, what you might run into is you might run into something in a cyclo. This means all the carbons are connected. Okay, usually in like a circular structure, or maybe it's not even always circular. Could just be in any way. It could be a triangle if there's 3. It could be a square if there's 4. Right, it all depends on how many there are, but all the carbons are connected when you have C-cyclo. So that's just for carbons. All right, just also remember when we're talking about anything besides carbon, like fluorine, chlorine, bromine, iodine, oxygen, those things, you're still going to run into the mono and the dis and the tris and the tetras. Okay, so don't forget about those ones as well. All right, so these are just specifically for carbons. These are for non-carbons, so non-organic stuff. So when we have prefixes, we're going to have endings, which are suffixes. For carbons, if I have an ending that goes in A and E, which are called alkanes or anes, that means I have only single bonds between the carbons. And remember, a bond consists of 2 electrons per bond. And then we have ENE endings. That's going to be a double bond, which means 2 lines. And then we have YNE endings, which are going to be triple bonds, which are going to be 3 lines. All right, so a single bond will probably look something like this. A double bond will likely look like this. And a triple bond will look something like this. All right, and remember there's 2 electrons per bond because those guys are sharing. All right. Some other endings we might run into, which not at the beginning but more at the end. If we have OL, that's an alcohol. That means we have a OH group somewhere in the molecule. All right, and also there's going to be ones like AL and O and E, and what else we got? And there's esters, and so on and so forth. So this means you have a carboxylic acid group. This means you have a ketone. This means you have an alcohol in there somewhere. And then you're going to have ethers and ethers, methyl ether, things like that. So there's going to be other things that we're going to run into, but not at the beginning. This is going to be more at the end, all right, which will hopefully make sense as we get into those ones. So some simple examples that we can do. Pentane. All right, pentane. Pent means 5 carbons. Ane means single bonds. So I draw my 5 carbons out. And remember, carbon wants to bond 4 times. So that means the rest of the bonds are going to be hydrogens, unless otherwise noted. So you assume that you know the hydrogens. So lots of times, writing all these hydrogens can get very, very lengthy and time-consuming. There's a short way of doing this. This is like the structural formula. There's also a line formula. 1, 2, 3, 4, 5. This is the same as this. This is the line, and this is the structural. I have to work on my spelling. Structural formula. Each end of a line has a carbon with some hydrogens attached to it, and you should know how many. And these junctures are going to be lines too. So if I take it a step further and I go to pentene, I still have 5 carbons. But now This E and E tells me I have a double bond. Oops. E and E tells me I have a double bond. This 2 tells me the location of the double bond, so it's not the second one. So that means I have a double bond here. And then again, I have to fill in my carbons. Or my hydrogens, sorry. And these are all hydrogens. If I did a line drawing, it would look like this. There's my double bond. And then if I went even further than that, I said, let's try a triple bond. So let's say I go 1, 3 pentyne. That'd be a C here. That's still 5 carbons. And a pentyne means I have a triple bond at the first and third. So there's a triple bond here and a triple bond here. And then I fill the rest in with hydrogens. So this guy only needs to bond one more time. There's a hydrogen. This guy's already got 4. This guy's already got 4. This guy's got 4. And then this guy needs 3. And how would I draw that with a line drawing? Go 1, 2, 3, 4, 5. Whoa. There's 5. I have 3 bonds here. And then I have 3 bonds here. 1, 2, 3. And there you go. And there's my line drawing. All right, so there's lines, there's simplified versions of drawing, and then there's structural ones. You have to know these to know how these work. But there's your intro to the regular stuff. Hope that helped. Do some further reading or stop the video and rewind it. Hopefully you get some more practice in class.